Welcome to EDU World Space.
Okay, in this question, we know that the total energy, the power on R1 is 15 volts. Okay, so we know that P1 equal to 15 volts is equal to the current goes through R1 I1, which is I1, times the voltage on R1 V, because these three resistors are in parallel. So basically this V is the EMF. So this is equal to 15. I equal to 2. So we can know that the V is equal to P1 over I1, which is 7.5 volts. So this is the EMF. Okay. Now we know the EMF. We can know that R1 equal to V over I1, which is 7.5 divided by 2, and it's going to be 3.75 ohm. That's R1. So for R3, now we know the EMF, we know its resistance. So the current could go through R3. R3 is going to be V equal R3, and it's going to be 0.75 ampere. And the current goes through R2, since we know that I1 plus I2 plus I3, the current goes through all these three resistors. They are in parallel. The sum of their current should be equal to the total current, which is I, and it's 3.5 ampere, right? Here is 2, here is 0.75. So you can have that I2 is also equal to 0.75 ampere. Since I2 and I3 are equal to each other, which means R2 equal R3, right? So it's 10. So now we find out that the EMF, we find out what are the resistance of R1 and R2, and we find out what's the current in each branch of the circuit. So now the power of the system, the total power, is going to be equal to the EMF V times the total current I. So it's going to be 7.5 times 3.5, and it's going to be equal to 26.25 volts. And the power on each single one of them, so P1 we already know 15. Since R2 and R3 are equal to each other, they have the same voltage, they have the same current. So P2 equal to P3 equal to the current times the EMF, and it's 0.75 times 7.5, and it's equal to 5.625 volts. And we can know that, we can see that P1 plus P2 plus P3 is just equal to the total power, which proves the conservation of the energy.